Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 12 from the specimen paper for the 2025 syllabus. This is paper 4. This is the first specimen paper for A, and this is for the Cambridge syllabus here. And as we know, the syllabus changed in 2025. Now here's a question which is about estimating the mean from a grouped frequency table. So we're told that the height in H centimeters of each of the 100 students is measured. The table shows the results. So we get the height in groups. So all those students that their heights were were greater than 100 up to 150, they were placed in this group. And those between 150 up to and including 160 in this group, and so on. So the heights, the students have been grouped according to the height in these different categories. Now, we don't have the original data with us, so we don't know exactly what the height of each of these students were. So I know 7 students were somewhere between 150 and 150 centimeters, but I don't know exactly what their heights were. That's the reason why we are not able to find the mean, and we have to calculate an estimate of the mean, because we don't know the actual heights of any of these students. So because we don't know the actual heights, we cannot find the mean. Now remember, the mean is an average, which is the sum of entries, the sum of all the entries divided by the number of entries. Okay, that's how you find the mean of a set of data. So because we don't know the values of any of the data entries, then we cannot find their sum. So we have to do something to find an estimate of the sum. We have to estimate the sum of the entries, and that will help us to give an estimate of the mean, because we know that how many entries there are. The question tells us that there's 100 entries. And we can, even if they didn't tell us, we can see there were 7 entries here, 30 entries there, 41 entries there, 22 entries there. Of course, it will add up to 100. So we have to do something to estimate what these values, these 7 values were. Now, we can't really do anything like, about it, apart from the most sensible thing, which would be, let's just say those entries, all 7 of them were halfway between these. Some might have been more than a half, some might have been less than a half, and it might average out. With nothing else we can do, that's the best we can do. So that's why we take what's called the mid-interval value. The mid-interval value, okay? The mid-interval value, which we're going to call X, and this frequency, we call it F. So when I want to find the estimate of what these 7 entries add up to, if I want to add the 7 entries together, I will just take this 7 and multiply it by the mid-interval value. So what's the mid-interval value? Well, it's the value exactly halfway between these two numbers. So between 100 and 150, halfway is 125. Now, if you're not sure, if you can't work that in your head, you can use a calculator. It's like finding the midpoint. You just add the 2 numbers together and divide by 2. So 100 plus 150 divided by 2, which gives you 125. And 150, 160, you can work that in your head, but if you didn't know how to do it, just put that in the calculator. Between 160 and 165, it's going to be 162.5. Between 165 and 185, halfway will be 175. 10 between this and that, 10 between that and that. Halfway, exactly halfway. All right, again, if you don't know how to do that in your head, you can just use a calculator. So we are going to estimate that these 7 entries are all 125. And these 30 entries are all 155 centimeters. These 41 entries are 162.5 centimeters, and so on. And that will help us give an estimate of the total sum of those 100 entries. So we're going to take F times X for each of these. Find the sum of all the fx's divided by the number of entries, okay, which can be found if it's not given. It's basically just the sum of all the f frequencies, sum of all these. Okay, but we know it's equal to 100. So now we can just do the multiplication. So we're going to do 7 times 125 plus 30 times 155 plus 41 times 162.5 plus 22 times 175. I'm going to divide all of that by the sum of the frequencies, which is 100. Okay, always check if that is mentioned in the question before you start adding these together, right? Save time. Now, we're going to put this in our calculator, and you have to be very, very careful because it's so easy to type something incorrectly, to type out multiplication instead of an addition and vice versa, or to just lose a digit or to add an extra digit when you're using your calculator. So you have to be very, very careful about how you get your answer. So I'm going to put my fraction bar. I'm just going to type this in. So 7 times 125 plus, just take 7 times 125 plus, and then 30 times 155, 30 times 155. Okay, now 30 times 155, 30 times, oh, there's an extra 5 that came there. Always check, right, at every step in case you've typed something wrong. Plus, okay, plus, and then 41 times 162.5, 162.5. Okay, now 41 times 160, see, again, that's supposed to, there's a 4 there. It's supposed to be 162.5. So always check at every step that you haven't typed something incorrectly. So easy to make that mistake. So that's why you should always be checking. So you have plus 22 times 175 divided by 100. So 100. 100. Okay, and that equals 1283 over 8, 1283 over 8, which when you round that, it gives you what number? So you press SD, 160.375. All right, so this is one of those borderline cases. Do you write it down as this, or do you write it down as 3SF? Well, this is technically an exact answer. And as we know, exact answers should be written down as they are. Okay, if it continued a bit further than that, then we'd round it to 3SF. It's one of those borderline cases. I'll write it down as 160.375. But if you wrote it down as 160, it might be acceptable. Okay, but if it stops at 3 decimal places, I think it's better to write it in this format, because as long as it's not, if it's money, you should round it to 2 decimal places. But in this case, this is considered an exact answer. As we can see, if we go back to the original page of the paper, it says give non-exact numerical answers to 3 significant figures. Okay, so it says non-exact. The key word here is non-exact. So that would be considered an exact answer. So that's why we left it as it was. Okay, where did I get to? Yeah. Okay, so I think that would be fine as your answer, right? So there we have the answer to this question completed. Another thing that you should check before you continue, in case you made a silly mistake. So for example, supposing in my calculator, I put, instead of 100, I put 10. Or maybe I put 1,000, for example. Now, if I had put 10, then my answer would have been, let's show you. Supposing I divided by 10 by mistake. All right, my answer would have been 1,603.75. Now, there's no way that could be the mean weight of these children. Their mean weight must be somewhere between 100 and 185, somewhere between them. And as the majority of the weights are in the middle kind of region, they're going to be somewhere close to the 160s, 150s, whatever. There's no way the mean weight can be 1,603.75. No way at all, right? So that's something that you should, if you get a number like that, you know you've done something wrong. Or you might, for example, have typed an extra 0 by mistake, in which case you would have got 16.0375. Now, if you put 16.0375, of course, that's not their mean weight. Okay, the mean weight has to be somewhere in this region here. So if you do get an answer that's, not within this range, then you're for sure 100% you've done something wrong. Okay, so you should always have a way of checking to see if your answers are sensible in some of these questions. And that's one of those questions that you can very easily do so when you're finding an estimate of the mean. Okay, so that concludes this question. Other questions from this paper can be found in the playlist on the top right of the screen at the end of this video. Other questions from the topic of statistics in general can be found in this playlist. If you want to find specifically about how to estimate or calculate averages, whether from raw data or frequency tables or group frequency tables, you can find that in the playlist in this region. And on the top of the screen, I'm going to give like a link to my pre-2025 material on statistics, so you can see some other examples of questions from the previous papers. The only thing that you would not be relevant to you now would be anything to do with what are called box and whisker plots. They have been removed from the syllabus. Okay, so that concludes this question. Thank you for watching and see you soon.